Hello good dear viewers. In this tutorial we are going to find a solution to this exponential equation, and the equation is x squared minus x raised to the power of the square root of x equal to 0. If we solve this equation by factorization, we are only going to obtain one solution, but I know we have two solutions because 4 can satisfy this equation, likewise 1. But let us factorize it first. We may decide to bring any of these two terms out. Let me bring this one out. If we decide to bring x raised to the power of the square root of x outside, inside, applying one of the laws of indices, we take a base here, then we subtract the exponent. That is 2 minus the square root of x. 2 minus the square root of x. Then here already the whole of this term is outside, so we have minus 1. The whole of this equal to 0. Now it implies that either this or this must be equal to 0, right? So if we say that x raised to the power of the square root of x is equal to 0, or the other one, by setting this to be equal to 0, you can take -1 to the other side, which implies that x raised to the power of 2 minus the square root of x must be equal to 1. Here, the only condition that will make an exponential function to be equal to 0 is only if the base is 0. So if the base is 0, which means x equal to 0. If you substitute x equal to 0 back in here, you're going to obtain an undefined expression, because we're going to have 0 raised to the power of the square root of 0, which is the same thing as 0 raised to the power of 0, which is undefined. So we are not going to consider this one as a solution. Therefore, let us come here. We can write 1 as x raised to the power of 0. So this is x raised to the power of 2 minus the square root of x equal to x raised to the power of 0, which means that this exponent is equal to 0. 2 minus the square root of x equal to 0. If you take this to the other side, you have 2 equal to the square root of x. Square both sides, square this, square that. Power of 2 will eliminate square root, leaving only x, and 2 squared is 4. Therefore, x equal to 4, and hence x equal to 4 is our solution. But I told you 1 is also a solution. So why is it missing here? Let us apply logarithm in order to find the full solution to this problem. From here, we may decide to take this term to the other side, so that we have x squared equal to x raised to the power of the square root of x. And we can take log of both sides, right? We have log of x squared must be equal to log of x to the power of square root of x. According to one of the laws of logarithm, we can bring these powers down to multiply. This is 2 multiplied by log of x, right? This must be equal to square root of x multiplied by log of x. Bring this term to the left-hand side. We have 2 log of x minus square root of x multiplied by log of x. We have, okay, this must be equal to 0, right? We have log of x in common, so we factor 1 out. Log of x, inside we have 2 here, minus square root of x. This is equal to 0. We have 2 factors, log of x and 2 minus square root of x. It means that either log of x equal to 0 or 2 minus the square root of x equal to 0. Let us solve them separately. According to the definition of logarithm, you know this naturally has a base of 10. So 10 raised to the power of 0 must be equal to x, right? So x is equal to 10 raised to the power of 0. And 10 raised to the power of 0 is equal to 1. Therefore, x equal to 1. What about this one? Take this to the other side. You have, let me come here. You have 2 equal to the square root of x. Square both sides, square this, square the other side. You have x equal to 4. And hence we have 2 solutions here. X could either be equal to 1 or positive 4. x equal to 1 or x equal to 4 is our valid solution. I told you 0 cannot satisfy this equation. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.